Reconciliation is the final chapter in terms of the CIM best practices, and there are a number of items that the CIM recommends in terms of the best practices in respect to reconciliation. Firstly, the QP must take into account the results of any grade tonnage reconciliation in any public disclosure of mineral resources or mineral reserve estimates. So if any reconciliation evaluation has been conducted, then that must be taken into account when resources and reserves are being reported. Production monitoring involves the process of grade control and the subsequent tracking of the tons and grades of mineral material as it moves to the plant. This allows for the monitoring and minimization of dilution, the maximization of recovery, and attempts to ensure a constant feed to the process plant. Grade control involves sampling of production sources, establishing ore and waste boundaries, and accurately recording production tons and grade. Reconciliation is a check on the effectiveness of both the estimation and the operating practices. In terms of the reconciliation process, we're going to focus in more detail on the actual production monitoring process. So the production monitoring effectively is trying to minimize the dilution and maximize the recovery at the operation. When all waste boundaries are visual in nature, identification is much easier. However, production monitoring should still be conducted even in these scenarios to try to minimize the levels of dilution and maximize the recovery. Where assay boundaries are used to delineate ore, appropriately spaced representative samples are required to estimate the locations of economic margins. And given the negative economic consequences of misclassification, due diligence is necessary to ensure that mined ore and waste types are delivered to the appropriate destinations, and that we don't get ore being sent to the waste dumps and we don't have waste being sent to the mine plant. To ensure constant metallurgical balance, the ore may need to be characterized. And if this is the case, and it is non-visual in nature, other testing is required to achieve an appropriate level of blending. Monitoring of deleterious elements or byproduct constituents that might compromise or enhance mill recoveries and concentrate quality need to be conducted to reduce the likelihood of nasty surprises in the plant. The best practices also state that we should record accurately the production tons and grades to permit reconciliation of mine production to the processing plant and ultimately to the mineral reserve estimate and block model. Mine production needs to be reconciled to mine surveys on a regular basis, and that should at least be commonly every month. We must also ensure that accurate measurements of in situ bulk densities for various ore and waste types have been determined so that the volumes can be converted appropriately to tons. Periodic checks should be conducted and are required to test that the in situ bulk densities, truck and bucket factors, as well as weightometers, are all aligned and are all providing similar tonnage evaluations. It is also necessary to develop appropriate sampling protocols and continuously evaluate them to ensure representativity and sampling in both the mine and plant. It is important that we ensure that acceptable QA/QC procedures have been set up and are being followed at all laboratories being utilised for the assays which are being reported in the grade control process. It is also best practice to have maps of working benches at appropriate scales, and to keep volumetric surveys to be retained so that they can be checked in future reconciliations. And below we have an example of the reconciliation processes which are conducted by Fortuna and are implemented at any of our operations, San Jose or Cayoma for example. Within this we have the modelled evaluation as shown here by the short-term block model, where we would have the tons and the grades of the material which the short-term model predicts will be in the area that we plan to mine in the time period being evaluated. We would then be able to see what the planned amount of material was, both in terms of at the cut-off grade of interest and also for the total amount of broken material. Then when we come to extract that material underground, we can check the in situ model against the short-term resource block model. We can check the planned amount of broken material, including ore and waste, against the broken material which we see from underground. And we can also assess the amount of planned material above the cut-off grade, the material only registered as ore, and we can compare that to what is actually extracted and what is identified at ore. This ore material will then be sent to the surface, is weighed and on the balances. Some of that material may be sent to a stockpile, and the rest of the material may then proceed towards being sent to the plant. At the same time as this is being sent to the plant, additional material may be added from the temporary stockpiles. This material will then go into a transitional stockpile prior to being fed into the plant, and finally we'll have the plant evaluation, where we can monitor the exact amount of tons by weightometers on the conveyor belts, and we also have assaying at regular intervals of that material as it's set into the plant. Once it goes into the plant, it'll be concentrated, and we will produce the concentrate, and this will provide us with an idea of the types of metallurgical recoveries that we should be expecting. At the same time, waste material will be sent to the tailings, and we should also monitor exactly what the tons and grade of that material is. And finally, from where the concentrate is produced at the plant, ultimately it will be dispatched and shipped out, and at that point it will be reassayed, and we should be able to check that those values match up with what we have evaluated as being put through the plant. So this whole process allows us to monitor exactly where the material is moving, exactly the tons and the grade of that material through the whole process, and be able to spot any potential errors or issues as soon as they occur. And this is conducted on a monthly basis, and in terms of that we have a summary in terms of a tabulation in the bottom right hand corner, which allows us to quickly see whether we have any issues, which would be highlighted in the yellow or red colour. If we were to see issues that occur over several months, then we would become concerned, and we would have to look to see if we can adjust and change the process and find out exactly where our error or issue is occurring. One of the parts that the best practices particularly focuses in on is the reconciliation between the mine and the mill. There are a number of points in terms of this that the best practice recommends are conducted. Firstly, the reconciliation between the mine and mill production should be done on a regular basis, but monitored on a daily basis to ensure accuracy of sampling and record keeping. Current best practices is considered to be reconciled on a monthly basis. A reconciliation provides checks for discrepancies which may require changes to operational procedures or even the mineral resource, mineral reserve model and the parameters used in that evaluation. Mine production is usually reconciled to the plant, since measurements in the plant are generally accepted to be more accurate. Significant discrepancies Resulting adjustment factors should be explained and reported if any adjustments are required. On an annual basis, the mill production should be reconciled with the final concentrate, bullion or mineral shipped, and resulting adjustments factors should be explained and reported if there is a discrepancy between what the mill says is produced and essentially what is eventually seen and shipped as a final product. We can have a look exactly at how the mine and mill reconciliation is conducted at Fortuna's operations. As would have been seen from the previous spreadsheet flow diagram, we know exactly and monitor exactly the amount of material extracted by the operation. We then see exactly that amount of material which becomes the head grade which is fed into the plant, and we monitor from this the concentrate produced and the concentrate shipped. By monitoring these and comparing these three items, we can keep a close eye on exactly what the expectations are, particularly in terms of what type of metallurgical recoveries we might be expecting to see. As we can see in this example here, a metallurgical recovery of 88.9% is being achieved for the silver and 88.6% for the gold, and we can double check to see whether that matches what our expectations are in terms of recoveries for the plant. We should also always see a very good comparison between the concentrate produced and the concentrate shipped. Any adjustments or any discrepancies between these two numbers have to be very carefully monitored, because this directly reflects the amount of payment that the operation and mine will receive. The next aspect in terms of the best practices focuses in on the mineral resource, mineral reserve reconciliation process. And the best practices state that reconciliation of the long-term mineral resource, mineral reserve block model should be done at least annually to coincide with the corresponding mineral resource, mineral reserve statement. The reconciled production to estimated depletion of mineral reserves should be undertaken. It should be especially noted here that this is in particular relation to the mineral reserves, because that is the easiest component to reconcile when we're talking about production, because production involves the end product, so therefore dilution recoveries will have been taken into account in terms of the production, and the only reconciliation we can do that to directly is the mineral reserve and not the mineral resource. Any discrepancies in grade and or tons should be explained, and appropriate changes should be made to operating practice or the mineral resource, mineral reserve estimation process, or parameters such as the dilution and the recoveries which are being applied. Remaining mineral resource, mineral reserves at operating mines should be reviewed at least annually and should reflect changes in the underlying criteria. So if there's been alterations in the long-term metal prices, or decreases in costs, changes in metallurgical processing, and other alterations such as in the mining methods, the types of dilution or recovery that are being seen, these should be evaluated and assessed and taken into account in the mineral resource, mineral reserves on an annual basis. Additionally, cut-off grades or economic limits should be reassessed and updated at least annually. And remaining mineral resource, mineral reserves should be adjusted for improved geological interpretation. So if we've had any additional drilling, mapping, channel samples taken, anything which will have allowed us to better define the geological structures, then this needs to be taken into account as part of the annual update. So in terms of the mineral resource, mineral reserves, the final evaluation should be compiled of a reconciliation which compares the previous estimate to the new estimate. So it's a year-on-year evaluation which should be conducted annually. And in this sense, we should produce a balance sheet or a waterfall diagram detailing all the changes due to such items as mining extraction, changes in the commodity prices, additions or depletions due to drilling or mining losses, sterilisation, or any other aspects which may have resulted in a loss or gain in the mineral resource, mineral reserve, must be clearly explained and defined each time the update is conducted, generally on an annual basis. So let's have a quick look at an exercise in terms of reconciliation. I'm going to have a look at a monthly reconciliation, and do you see any issues, and how could this have been improved potentially? So take a minute to have a look at the below set of numbers where we're showing the extracted numbers as compared to the plant, and also the types of tons and grade that have occurred from month to month in terms of the coarse reject stockpile and as in terms of the fine stockpile. So the first thing which may have jumped out when we're comparing the two sets of numbers is that we have quite a difference between what we've stated as being the mineral extracted and what we actually see in terms of the plant for the silver grade. We have a silver grade of 231 grams per tonne for the mineral extracted, and yet we're only seeing 189 grams per tonne in terms of that seeing in the plant. In terms of all the other aspects, the amount of tons which are being extracted and the grades in terms of lead and the zinc, then we're seeing very similar sets of numbers. So immediately that gives us cause for concern to suggest that if the plant numbers are correct, and we can assume that those are because they are directly monitored and directly evaluated, then the estimate of the extracted silver grade may be the problem and therefore requires further evaluation. When we then have a look at the grades in terms of the coarse stockpile, we can see that the amount of tons in the coarse stockpile has increased from 13,000 up to 15,000, so we've had more material sent to the stockpile in this month. But we can also see a fairly dramatic increase in terms of the silver grade. It's risen from 275 to 352. When we look at the amount of material that's gone from the coarse stockpile into the fine stockpile prior to being fed into the plant, we can see that that amount of tons has stayed very similar, and we have seen a similar type of grade in terms of the silver, 182 and 184, and quite a similar ending up product as being output from the plant. This would suggest that we have quite a number of tons of higher grade silver content material presently being left in the coarse stockpile. If this is the case, and we need to be careful that this is the situation and we are seeing these types of grades as in from our sampling, and we may want to double check that that sampling is correct, then what we would hope to see is in the following month some of this high grade silver content will be pushed through and into the plant in the coming month, and we should in the following month see higher grades in the plant than what we should find upon extraction. In this way we can keep an eye in terms of how we are achieving and how we are monitoring the month by month production targets.